Hi everybody, this is an intro to the information you need to know for the U substitution lecture. If you're using the U substitution with a definite integral, these are the integrals, remember, where you've got a number up top and a number on the bottom, where you've got your limits. Okay? For these, the key things we need to pay attention to, you're doing the same exact steps. The only additional point, at the end, you're going to use the formula for U to correct your endpoints. And then you're going to evaluate, so you're going to plug them in, and then you'll be good. Okay? So let's run through an example, because that's the only way we do it. This is the same examples we had earlier, only we have endpoints now. So we have our integral from 0 to pi of 2x times cosine of x squared differentiated with respect to x. So our inside function again is x squared. We've got our x squared. Derivative is 2x dx. Derivative is 2x dx. So we got those suckers are gone. We're left with cosine of u. Finding the antiderivative of cosine u is sine u. So you plug in the x, you got sine x squared. Now for your endpoints that are changed, all that means is you've got to plug in those two endpoints we had, the 0 and the pi, into our original equation where we've got our x squared. So basically, if you've got whatever you have for your u, you have to do that to your endpoints as well. So you've got pi squared and 0 squared. So in the end, we're looking for the integral, we're looking for sine x squared evaluated from 0 to pi squared. So that means we're going to end with sine of pi squared, not to the third. In the end, we're left with sine of pi squared minus sine of 0. You don't even have to simplify it beyond that, and you're done. For the second example, if we have, same example as before, where you've got your 2x plus 8x, your 2x squared plus 8x, all of that to the sixth, and your x plus 2 with the integral evaluated from 1 to 3 with respect to x. We have to then figure out what our u's going to be. Our u, just like before, is going to be the 2x squared plus 8x. Get rid of that almost right away. Now we have and the derivative of the 2x of our u, right? 4x plus 8. When you factor that out, it goes down to 4x plus 2. So we have to pull that 4 out, and we've got our 1 over 4, because you're taking the 4 that was brought out with the 4 by 4 that we had on the outside, and you're distributing it in the middle, rather than leaving it at one end. Alright? So we now have this guy's covered, this guy's covered, your dx is taken care of. All we got to figure out is what our u to the 6 is with our 1/4 on the outside. Okay? And remember, we're going from our 1 to 3, which means what we're doing is we're plugging in the values we had. We got to change our endpoints by plugging in the 1 that we have into our u, our 3 into our u, all of those for x. So our endpoints are going to change from 1 to 10, and from 3 to 42. So when we do the simple math for that portion, you've got 1/4 times u to the 7th over 7, which ends up being u to the 7th over 28, which when you plug it in, you end up with as follows. All right. Now for the last bit of your answer, you have to evaluate for your integral using the endpoints, the new endpoints, not the old ones. So that means we have got to plug in our 42 and our 10 and subtract those answers. Your final answer should be something along the lines of 3864 to the 7th minus 280 to the 7th.